Specific heat. If equal amount of heat is supplied to equal mass of different substances, the resulting temperature changes will not be same. This shows that each substance, when unit mass is considered, has a unique value for the amount of heat absorbed to rise the temperature by 1 unit. That is, materials are characterized by specific heat capacity, or simply called specific heat. That is, the nature of the body in absorbing heat to rise its temperature is defined in terms of specific heat. Activity. Take a large jar with water and heat it up to 80 degrees Celsius. Take 2 identical boiling test tubes. One of them is filled with 50 grams of water and the other with 50 grams of oil. Keep them at room temperature. These test tubes are covered with single-hole corks which are arranged separately. Insert 2 thermometers through these holes of the corks, one into each of the test tubes. Now place the both test tubes in a jar of hot water. In which test tube does the temperature rise quickly? The same amount of heat is applied to water and oil because they are kept in the jar of hot water for the same interval of time. The rate of rise in temperature of the oil is higher than the rate of the rise in temperature of the water because rate of rise in temperature depends upon the nature of the substance. Activity. Take 2 beakers, in which one is small beaker and the second one is large beaker. Take 250 ml of water in small beaker and 1000 ml of water in larger beaker. Note the initial readings of the 2 beakers with water. Now heat both the beakers till the temperature of water in the 2 beakers rises to 60 degrees Celsius. Note down the heating times required to raise the temperature of water to 60 degrees in each beaker. Which beaker needed more time? The time required to rise the temperature of water in larger beaker is more than the time required to rise the temperature of water in a smaller beaker for the same change in temperature. Specific heat of a material is defined as the quantity of heat required by unit mass of the material to rise its temperature by 1 unit. It is denoted by S. Its SI unit is joules, kg inverse, Kelvin inverse, and CGS unit is calories per gram degree Celsius. If delta Q is the quantity of heat supplied to a substance of mass m to rise its temperature by delta T, then specific heat of the substance is given by
S is equal to Q by m delta T.
Hence, specific heat of a material of a body is also defined as the heat capacity per unit mass of that body. If the amount of substance is specified in terms of moles instead of mass in kg, we define the heat capacity per mole of the substance known as molar specific heat capacity. The SI unit of molar specific heat capacity is joules mole inverse K inverse. The quantity of heat required to raise the temperature of 1 mole unit mass of substance is known as the molar specific heat capacity of the substance. But in case of gases, heat is to be supplied to the gases by keeping pressure or volume constant.
If the pressure of gas is maintained constant during the heat transfer, the corresponding heat capacity is molar specific heat of gas at constant pressure. We know that the temperature of a body is directly proportional to the average kinetic energy of particles of the body. Activity. The molecules of the substance have different forms of energies such as linear kinetic energy, rotational kinetic energy, vibrational energy, and potential energy between molecules. The total energy of the substance is called internal energy of the substance. When we supply heat energy to the system, the heat energy given to it will be shared by the molecules among the various forms of energy. Applications of specific heat capacity. Now, we all know that the specific heat of a substance is the amount of heat required to raise the temperature of unit mass of substance by 1 unit. We can determine the amount of heat required to raise the temperature of a certain mass of the substance by some degrees. This is done by the equation Q is equal to ms delta T, where m is constant, S is the specific heat of a substance, and delta T is the change in temperature. Here are some examples where specific heat capacity comes in hand. Sun is the ultimate source of energy on Earth. As water has high specific heat capacity, oceans near the equator absorb lot amount of energy and store it to maintain a balance of temperature on Earth. The heat absorbed by the ocean water is transformed to the regions away from the equator so as to balance and maintain moderate climate in those regions. The fact that water has high specific heat can be proved by an example that watermelon taken out from a refrigerator remains cold even after a longer time. Stuffed food is cold outside, but when opened, inner contents maintain hotness due to their high specific heat capacity. Method of mixtures. A method of determining the heat of fusion of a substance whose specific heat is known, in which a known amount of the solid is combined with a known amount of the liquid in a calorimeter, and the decreases on the liquid temperature during melting of the solid is measured. Activity. Let us take 250 ml of water at 85 degrees Celsius. And 400 ml of water at 55 degrees Celsius. Both are mixed with each other in another beaker. What is the temperature of the mixture? Let us find out. Let the initial temperatures of the samples of masses are M1 and M2 be T1 and T2. Here T1 is the higher temperature and T2 is the lower temperature. Let T be the final temperature of the mixture. The temperature of the mixture is lower than the temperature of the hotter sample, but higher than the temperature of the colder sample. That means the hot sample has lost heat and the cold sample has gained heat. The amount of heat lost by the hotter sample Q1 is equal to m1s into T1 minus T. The amount of heat gained by the cooler sample Q2 is equal to m2s into T minus T2. Heat lost by the hotter sample is equal to the heat gained by the cooler sample. That is, Q1 is equal to Q2. So, m1s into T1 minus T is equal to m2s into T minus T2, which can be simplified to final temperature is equal to m1 into T1 plus m2 into T2 divided by m1 plus m2. Principle of method of mixtures. If bodies at different temperatures are brought into thermal contact with each other, heat flows from the hot body to the colder body until they attain thermal equilibrium. When a body at higher temperature is brought in contact with another body at lower temperature, then the heat lost by the hot body is equal to the heat gained by the cold body, provided no heat is allowed to escape to the surroundings. If heat is not lost by any of the process, the heat lost by hot body is equal to heat gained by the cold body. This is known as principle of method of mixtures. Determination of specific heat of a solid. According to the principle of method of mixtures, when two bodies with different temperatures are brought into thermal contact, net heat lost by the hot bodies is equal to the net heat gained by the cold bodies. Now, let us perform an activity to determine the specific heat of a solid. Materials required by this activity include calorimeter, thermometer, stirrer, water, and lead shots. Let the mass of the calorimeter along with stirrer be as given m1. Let 1/3 of the volume of calorimeter is filled with water and its mass along with water be represented as m2. Hence, mass of water is equal to m2 minus m1. Let the temperature of water in calorimeter is equal to T1. Now, water and calorimeter are at same temperature. Heat some lead shots in hot water at 100 degrees Celsius. This temperature of lead shots is equal to T2. Hot lead shots are transferred into calorimeter with negligible amount of heat loss. Now, temperature of calorimeter with water and lead shots is equal to T3. Mass of calorimeter with water and lead shots is equal to m3. Mass of lead shots are calculated to be m3 minus m2. As there is negligible amount of heat lost by lead shots, entire heat lost from the lead shots is transferred to water in the calorimeter. That will be the final temperature T3. Specific heat of calorimeter is equal to Sc. Specific heat of lead shots is equal to Sl. Specific heat of water is equal to Sw. Heat lost by solid is equal to heat gained by calorimeter plus heat gained by water. m3 minus m2 into Sl into T2 minus T3 is equal to m1 Sc into T3 minus T1 plus m2 minus m1 into Sw into T3 minus T1. Therefore, Sl is equal to m1 Sc plus m2 minus m1 into Sw into T3 minus T1, the whole divided by M3 minus M2 into T2 minus T3, where SL is the specific heat of lead shots. Hence, it is calculated or determined. This is determination of specific heat of a solid.